Guys, Assalamualaikum and good afternoon. Can you guys hear my voice? Boleh ke?
Waalaikumsalam sir. Boleh sir.
Waalaikumsalam, sir.
Alright. Thank you. Okay. So we'll move on with the next subtopic for sequential circuit lah. Okay. So obviously last week sepatutnya kita belajar pasal benda ni, but it was on holiday on the lectures day, so kita terpaksa tunda. Alright, so sepatutnya minggu ni saya nak ajar new topic quarters 2, tapi itulah everything has been delayed. But tak apalah, kita jangan pening-pening. I'll just move on as normal macam sekarang ni. Okay, so I'll start with the FSM today. And then next week pula kita dah raya, so obviously tak ada kelas lagi. Then after raya lah, saya akan fikirlah macam mana untuk kita catch up the 2 lecture class, iaitu minggu lepas dengan next week. Okay, last week kita tak ada kelas, minggu depan pun kita tak ada lecture. So after raya nanti I'll come up with an idea macam mana kita nak ganti supaya kita boleh kejar syllabus lah. Okay, sebab quarters 2 tu might be, we might be spending a lot of session lah dekat situ, mungkin 3 ke 4 session untuk you buat you punya lab practical terus. But don't worry about that lah, nantilah kita fikir pasal tu. Okay, so today I will proceed with FSM, finite state machine. So just to inform you that this notes yang saya guna hari ni is a new notes. Okay, saya dah upload for both dekat digital electronics principle dengan digital electronics. Okay, go to lecture notes, saya dah ganti dekat topic 4 ni. Okay, I'm using a new one because I think this is a better version for you to understand about finite state machine. Okay, especially on the examples later on. Alright, so FSM stands for finite state machines. It is also what we call it, categorized as one of the sequential circuit lah. Okay, other than counter, okay, flip-flop, latches flip-flop, and then we use flip-flop to design counter, and then we use flip-flop as well to design FSM. Okay, so FSM is a tool to model the desired behavior of a sequential system consists of several states. Inputs into the machines are combined with the current state of the machine to determine the new state or next state of the machine. Okay, so input will be a very important part for this FSM lah. Okay, if you remember clock, for counter input yang paling penting adalah clock. Itu saja. But this one you need clock, and then we need external input to determine the what the state will be and what is the input and output it becomes. Alright. So the example of FSM design procedure is by using melee or more machine, where both can be used to represent any sequential system and each has its advantages. Okay, so ada dua jenis lah untuk FSM ni. So we look into the first one and the type of machines that we are going to use lah. Kita akan guna yang jenis yang ini, melee machines. Okay. Okay, so for melee machines, the output is dependent on the inputs and the current state. Okay, so input tu dia bergantung kepada input dan juga current state. Okay, and associated with the state transition. Okay, so dia berkaitan juga dengan state transition. State transition ni adalah yang line-line ni. All those lines daripada state ini pergi ke state dia sendiri, atau pergi ke state ke depan, ataupun pergi state belakang. So that is the transition line. And it appears before the state transition is completed by the next clock pulse. Okay, meaning that dia tak perlu sampai ke state baru dia ada output. Okay, macam ni kan. Dia input dia satu, output dia dah boleh jadi satu. Dia tak sampai pun lagi dekat odd ni lagi. So that is what it means lah. Self arcs must be shown because the output values are shown on the arcs. Okay, so self arc ni macam ni, even ni if you look into this arrow here, yang dia patah balik kepada dia ni. Okay, so this must be shown for melee machines. Okay, if you look into all this transition line, dia ada dia punya numbering. 0/0, 1/1, 0/1, 1/0. Okay, so you have to know the one in front is known as the input. The one on the after the slash, that is the output. Input, output sama. Ini input, output, input, output, input, output. So this is the transition up. Putar balik, pergi ke sini. Okay. And the output is dependent on the current state and input. So dia perlukan input dekat depan ni. So that is milli machine. For more machine, output is dependent only on the current state. Dia tak perlukan input. Okay. And associated with the state, hence appears after the state transition take place. So dekat sini, ayat yang pertama ni, if you compare with these words here, untuk milli ni, kita dapat tengok apa beza dia. Okay, apa dia punya output depends on what. And then adakah dia associate with the state ataupun dia associate with the transition line. And then output kita dapat sebelum transition habis ataupun selepas transition habis. Okay, so obviously for more, dia perlu pergi ke sini dulu sampai odd baru dia dapat output. Sebab kalau kita tengok, this is the output yang dekat dalam ni. Even 0, odd 1. Yang dekat atas transition line ni hanya dia punya input 0, 1, 0, 1. Okay, so kita tengok balik milli, dia punya output dekat belakang ni, 0 dekat belakang ni. Input dia yang depan. So dia tak ada dekat dalam ni. Okay, this one even 0, odd 1. This is the output. Okay, output is dependent only on the current state. So that's why we read or we write the value of the output dekat dalam state. Okay, so that is the different. That is the difference between milli and milli machines and more machines. But as for this semester, you tak perlu risau pasal more lah. Kita akan buat dekat milli sahaja. So how to design FSM? So there are 5 steps, but steps number 3 ni I think I'll skip untuk kita lah. There are steps for state minimization, tetapi saya tak apply sangat lah untuk kita design for this semester, especially for your lab simulation with your final exam. Okay. First, you have to draw the state diagram and then the state transition table using the JK flip-flop punya excitation table, same way as JK counter. And then we do the next state logic minimization by using K-map and then we design. Okay, step minimization ni ada step dia tapi saya tak tunjuk dululah untuk you all. Right? Okay, first one, the state diagram. So this is how you differentiate between milli and more. So kita guna yang milli. For milli machine, each transition arc is labeled by a pair. Input condition and then output. Okay, transition condition input 1 / output. Okay, this is the state 1 and 2. Okay, yang ni pula transition condition 2 and then output 2. For more machine, each state is labeled by a pair, state name / output. So state 1 / output 1. So if you look into these two state diagram between milli machine and more machine, you look at where the blue colored writings are situated. Okay, contohnya ni output 1 ni kedudukan dia dekat line ni lah, yang 1/0, 0/0, 1/1. So output tu dekat bawah, dekat atas line selepas slash. For more machine, output tu berada di dalam state. So hanya ada transition condition sahaja dekat kita punya transition line yang anak panah keluar ni lah. Okay, so we are using this one, milli machine. Okay. Okay, example here. To recognize the sequence of 1, 0. So don't worry, apa tu 1, 0 memang you pun belum faham lah. Kita belum tengok lagi cara macam mana nak lukis. Okay. So state 0 is the first state where no elements of the sequence is observed. State 1 is the state where 1 is observed. Maksudnya kita dah jumpa 1. Okay, so kita tengok dekat sini nak detect 1, 0. State 0 will go to state 1 whenever it finds the first bit, iaitu 1. So dia jumpa 1, output dia 0. Okay. Why output dia 0? Because it only found the first bit. Dia baru jumpa 1. Dia belum jumpa 1, 0. It hasn't met 10 yet. So state 0, 1 pergi sini, and then 0 dia pergi ke sini. Okay, why? Because remember, each of the states must have 2 output lines. Okay, setiap state mesti ada 2 output line. Satu dia jumpa 1, satu lagi yang dia jumpa kosong. So state 0 will go to state 1 bila jumpa 1, but dia akan self arc kalau dia jumpa kosong. Right, sebab apa? Dekat sini kita jumpa 1. Dekat sini kita jumpa kosong. Right, and then same goes to state 1. Kita nak jumpa 1, 0. So dekat sini kita jumpa 1, dekat sini patah balik ke sini kita jumpa 0. Why? Because state 0 jumpa 0 pergi 0, state 0. So state 1 pun sama, bila jumpa 0 dia pergi ke state 0. Okay, but the output will becomes 1. Okay, dekat sini kenapa? Sebab dia dah jumpa 1, 0. How does it found 1, 0? Here. From here to here, dia jumpa 1. From here to here, dia jumpa 0. So 1, 0. So you get this number. Then your output becomes 1. Okay, but don't worry. I will explain to you later on macam mana nak faham berkenaan dengan lukisan ni. Alright. So this FSM, we normally use them as a sequence detector. Okay, maksudnya we have series of sequence of data, for example. Contohnya macam ni. 00100, kita ada data macam ni lah. Panjang lagi lah. But we want to detect, in this case, we want to detect bit 010. Kita nak detect 010 in a synchronous data stream. So whenever we found 010, output akan jadi high. Output will become 1. Okay, so we look into the condition of overlapping to detect bit 010 in this stream. Okay, so the first one yang kita akan jumpa 010 adalah dekat sini. Okay, so this is 001 and then 010 and then 100 and then 000 and then 0001 and then kita jumpa balik 010. Then we meet the second 010. Okay, and then 101, 010. Yes, di sini kita jumpa lagi satu. Tapi yang ini overlapping, so kita boleh detect the third 010. So the first one yang saya roundkan merah, yang second orange, yang ketiga hijau. Okay, next one saya jumpa dekat sini lah. Okay, so saya colorkan biru. Okay, and then the last one, selepas dia saya jumpa lagi satu, warna yellow. So there are 5 detection of 010 in this data stream. Merah, orange, hijau, biru, kuning. So this is for overlapping punya case. We look into the non-overlapping punya case, same data stream, right? The first one kita jumpa yang sama warna merah. But the second one, orange tu, dia akan, the second one is still the same. The third one, yang hijau tu tak ada. But we find the blue one as our third detection. And then yellow pun tak akan ada. Yellow pun tak akan ada sebab dia adalah non-overlapping. So we look into this case here. The difference between overlapping and non-overlapping is overlapping allows the detection to use same bits more than once. Okay, apa maksud dia? 010 you detect satu detection lah, 010. And then the same 0 yang belakang ni menjadi 0 yang pertama untuk detection yang seterusnya. So dekat sini dia ada overlap, nampak? Kosong ni digunakan sebagai bit ketiga untuk detection orange. And the same zeros become the first bit of the green detection. So dekat sini dia ada overlap. Same goes here, 010. So this third bit is the third bit of the first detection, and then this 0 as well is the first bit of the second detection. So kita dapat 2 detections itu. So 1, 2, 3, 4, 5. For non-overlapping, this green colored kita boleh ignore because kita tak benarkan overlapping. So dekat sini tak ada detection. Same goes to the yellow. Dekat sini pun tak ada detection. So for overlapping, you have 5 detections. So 5 kali output akan jadi high. For non-overlapping, you ada 3 detections, hanya 3 kali output yang jadi high. So that is what overlapping and non-overlapping is all about. So you have to understand, kalau soalan kata overlapping macam mana, kalau soalan kata non-overlapping macam mana. Okay. Alright, so how to draw the state diagram? So let's design a 100 detection. Okay, tadi 010 kan, sekarang kita buat 100. So this step is very important because why? If you draw these things here wrongly, kalau you lukis benda ni salah, then the whole steps yang you buat, dia punya state table, dia punya K-map and dia punya circuit diagram punya drawing will be wrong. I can assure you that. So this point here is very important. Bukan macam counter. Counter ni diagram tu tak terlampau critical. Okay, you might be wrong bila lukis tu, tapi bila you transfer to the state transition, mungkin you tak refer pun kepada you punya diagram. So meaning that you can congak je, what is the number after this, what is the number after this, what is the next state. So it becomes, the possibilities for you to generate mistakes there kurang sikit. Instead of FSM ni, memang dia sangat penting. Okay, so you have to know how to design the state diagram. So now, let's design 100. So the first one, we draw the first state, which is state 0. Okay, so saya lukis state 0 sini. And then draw a straight line from state 0 to a second state, which is S1. As the first input detection 100. Kita nak detect 100. So saya highlightkan satu ni. Kita nak jumpa bit yang pertama. Satu ni. And write the input on the line. So state 0, one straight line to state 1. Dekat atas ni saya letak 1. That is the input. And then step number 3, draw a straight line from S1 to the third state, which is the state 2. And the second input detection, which is 1, 0 lah. Tadi kita dah detect 1, sekarang saya detect bit yang kedua. And write the input on the line. So state 0 going to state 1, jumpa 1. State 1 going to state 2, jumpa 0. Okay, so kita dah jumpa 2 bit. And then draw another straight line from S2 to the fourth state, which is the S3, as the third input detection, which is the last 0 here, and write down the input on the line. So it's 1, 0, 0. So this straight line from state 0 to state 1, state 1 to state 2, and state 2 to state 3 is the line where you found the detection. Kita jumpa apa yang kita nak detect, 100. So this is the found line where you find the 100 detection from S0 until S3. So saya terangkan kat sini macam mana you nak buat benda ni. Okay, now place the output after the input. Okay, note that only S2 to S3 outputs will be 1 because that is when the 10 detection completed. So apa maksud dia? From state 0 to state 1, you baru jumpa bit yang pertama iaitu 1. So you belum jumpa 100. You haven't found 100 yet. So the output will become 0. From state 1 to state 2, you found the second bit which is 0. So, you baru jumpa 10. You belum jumpa 100. So, the output is still 0. Okay, the third line here, from S2 to S3, you found the third 0. So, 1, tengok yang merah, 1, 0, 0. Maksudnya, you dah jumpa apa yang you nak detect. Once you have found what are the bits, what is the bit that you want to detect, then output dia automatically becomes 1. Maksudnya apa? Kita dah jumpa. Right? The sequence to be detected has been found, which is 1, 0, 0. Look into the red colored ni. Yang blue colored ni adalah output. Okay. Next step. Each of the state must have 2 lines. Saya dah terangkan tadi. Setiap state mesti ada 2 line yang keluar daripada dia. Okay. Which is for input 1 and input 0. Okay, so let's consider state 0. Input 1 has already been found. Betul tak? State 0 to state 1 kita dah jumpa 1. Okay, to state 1. So for input 0, it will save up to itself and the output will be 1. So dia dah jumpa 1, dia belum jumpa kosong. So bila dia jumpa kosong, dia patah balik kepada diri dia dan output dia kosong lah. Obviously kosong. Kenapa? Because we would like to detect 1, 0, 0. Tetapi yang you jumpa 0 sahaja. So kita tak dapat lagi lah. Dia jadi high. Dia hanya akan jadi high sekiranya dia jumpa 1, 0, 0. Okay. For S1, output 0 has been found. Okay, betul tak? Kita tengok boleh diagram tadi. S1 kosong dah jumpa. So dia belum jumpa 1. So for input 1, it will save up to itself as S1 is the state to go when you found the first one. Okay, kenapa? You tengok state 0, bila dia jumpa kosong, dia patah balik kepada diri dia. Bila dia jumpa 1, dia pergi ke state 1. So sekarang ni, state 1 pun sama. If state 1 found 1, dia akan pergi ke sini balik. Sebab di sini sahaja you boleh pergi bila you jumpa 1. Sebab state 0 dah buktikan, dia jumpa 1 pergi ke state 1. State 1 pun kena ikut. Bila jumpa 1, it will go back to state 1. And the output will be 0. Obviously lah. Sekarang ni umpama you jumpa 1, 1. Okay, so that is not the sequence yang kita nak. Kita nak 1, 0, 0. Tetapi kita jumpa 1, 1. Obviously, bukan yang kita nak. So, output is still 0. Yang lain tengah ni still maintain. Yang lain tengah ni, saya still ikut yang ni. Cuma saya pecahkan satu-satulah. Yang ini dulu, lepas tu saya masukkan yang kedua, lepas tu saya masukkan semua. Okay, for state 2, output 0 has already been found to state 3. Okay, state 2 dah jumpa kosong, pergi ke state 3. So for input 1, it will go back to state 1. So untuk input 1, dia patah balik ke sini. Dia tak boleh pergi balik kepada dia. It cannot save up to S2 because why? Because S2, you can only go to S2 whenever you found 0. Why? S1 has already proved that. S1 jumpa kosong, dia pergi ke S2. So you tak boleh save up, jumpa 1 pergi ke sini. So you have to go to the state where you can go when you found 1 as the input. Kita tengok yang 1 merah, dia pergi ke mana? Sini pergi ke state 1. State 1 pun pergi ke state 0, pergi ke state 1. State 1 pun pergi ke state 1. So state 2 pun sama, dia akan patah balik pergi ke state 1. Okay, so you look dekat ni, yang line-line yang merah ni lah. Untuk point 7, ini line merah dia. Point 8, this is the red line. Point 9, this is the red line. Okay. So you are basically apa yang you jumpa, state 0 to state 1, 1. State 1 to state 2, 0. Okay dah, 1, 0. But suddenly, dekat state 2, you terjumpa 1 balik. So 1, 0, 1. So you kena patah balik kat sini lah. You tak boleh pergi ke sini sebab sini kita jumpa 1, 0, 0. Tengok yang warna merah, tulisan merah. Yang belakang tu output. So whenever you found 1, 0, 1, obviously output will become 0 lah. Sebab you tak jumpa 1, 0, 0. You terjumpa 1, 0, 1. So dia takkan jadi high lah. Right? So that is for state 2. Now we move on to state 3. So for state 3, belum ada lagi. Okay, belum ada anak panah yang keluar daripada dia. Dia belum jumpa kosong and it hasn't found 1 yet. Kosong belum jumpa, 1 pun belum jumpa. So for input 0, it will go back to S0. Sebab apa? Because S0 is the state to go when you found the first 0. Okay, kenapa dia jadi first 0? Kita tengok garis lurus ni. This is 1, 0, 0. Maksudnya you dah jumpa apa yang you nak. Lepas tu you jumpa 1, 0, 0 and then you jumpa 0 lepas ni. So umpama state 0 jumpa 0 lah. Sebab you jumpa 0 yang tak guna. Right? Sebab you need the first bit to be 1. Betul tak? 1, 0, 0. First bit mesti nombor 1. But dekat sini dia consider sebagai state 3 ni jadi macam state 0 balik lah. Okay, bila dia jumpa kosong, dia umpama jumpa first bit kosong. So kosong yang tak digunakan. So dia patah balik ke state 0. Alright. Then kalau dia jumpa 1, 1, 0, 0. Okay, and then dia jumpa 1 pula. So dia jadi 1, 0, 0, dia jumpa 1 lepas tu. So maksudnya dia dah jumpa sama macam state 0, jumpa 1. Iaitu jumpa bit pertama 1. So for input 1, it will go back to S1 as S1 is the state to go when you found the first one. Okay, 1, 0, 0 and then 1 balik. So maksudnya bila you jumpa 1 dekat S3, you ada possibility nak jumpa 100 balik. So dia pergi ke sini. And then the output will become 0 lah. Sebab dia, yang ini memang dia tak ada overlap. So 100, this is the complete drawing. Okay. Now, you have completed the state diagram for 100 FSM detection. Note that each state must have 2 lines going out from them. Okay, state 0. Satu line jumpa 1, satu line jumpa 0. State 1, this line met 0, this one met 1. State 2, this line met 0, this one met 1. State 3, this one met 1, this one met 0. Must have 2 output lines. Okay, but the number of lines coming to the state can be any numbers. Okay, contoh. For state 0, kita ada 2 yang pergi, anak panah yang datang ke state 0, which is this one and this one. For state 2, only 1, yang ini dia pergi. State 3 pun sama, yang ini dia pergi. Tapi state 1, you tengok ada 1, 2, 3, 4 lines yang pergi dekat dia. So, number of lines coming to the state can be any numbers. But yang keluar daripada state only 2. Kalau you ada keluar lebih daripada 2 ataupun kurang daripada 2, means that you are doing it wrongly. Okay. So only one output will be high, which is when the detection is completed. So yang inilah, yang biru ni jadi 1 bila kita dapat 100. So 1, 0, 0. So output dia jadi 1. Okay. So this 12 step is very important. Make sure that you are able to understand on how to draw the state diagram. Okay, if you understand these steps, then you will have no problem to design any sequence yang kita perlukan. Okay, nak detect 000 ke, nak detect 010 ke, nak detect 111, 110. Just make sure you kena tengok, ikutlah step yang saya buat ni. Okay, setiap apa yang saya ganti, semua saya macam ni line, saya jadikan warna merah. Meaning that this red line represent apa yang saya terangkan dekat nombor 8. These red lines represent apa yang saya terangkan nombor 9. Ini pula 1 nombor 10, 1 nombor 11. Okay, so you should spend some time to understand these steps lah, these 11 steps. Okay, so that is the step of designing the state diagram. Sekarang saya tunjuk example dekat you. Okay, but like I told you just now, the most critical part for designing FSM adalah benda ni. Okay, this is very important. You salah buat ni, yang belakang-belakang ni semua salah. Ini, circuit design, K-map dengan state table. Obviously, dia akan jadi salah. So, this part here, you kena fokus lebih sikit lah. Okay, alright. Nanti saya akan beritahu apa yang boleh didetect, apa yang tak boleh didetect. Okay, kita akan discuss later on. So, to detect 111 using JK flip-flop, design and non-overlap millisequence. Okay, so non-overlap dengan overlap ni pun memainkan peranan. Dia ada beza. Okay, but tak apalah. Nanti kita tengok beza dia sekejap lagi. Now, I'm moving forward to the design first. So, 111 non-overlap. So, the straight line adalah detection yang kita jumpa 111. So, state 0 to state 1, 1, output is still 0. State 1 to state 2, 1, output is still 0. State 2 to state 3, 1, output is 1. Because kita dah jumpa, state 1 kita jumpa 1 yang pertama. State kedua, the second 2. State ketiga, kita jumpa the third, second. State kedua adalah the second ones. State ketiga, the third one. So, 1, 1, 1 kita dah jumpa. So, output dia jadi 1. Okay. So, state 0 dah jumpa 1, dia belum jumpa 0. So, dia patah balik kepada dia. State 1 dah jumpa 1 dan dia belum jumpa 0. So, the only state yang dia boleh pergi adalah state 0. Sebab dia tak boleh pergi state 1, state 2. State 2 kalau jumpa 1. State 1 kalau jumpa 1. So, yang boleh pergi ke state mana yang jumpa 0. So, yang jumpa 0 pergi ke dia adalah state 0. So, state 1 jumpa 0 pergi ke state 0. State 2, dia dah jumpa 1 dan dia boleh jumpa kosong. So, bila jumpa kosong, dia tak boleh pergi S3 sebab S3 jumpa 1. Dia tak boleh self arc kepada S2 sebab S1 pergi ke S2 bila jumpa 1. And then it cannot go back to S1 because S1, you need to go to S1 if you found 1 as the input. Proven by state 0. State 0 jumpa 1, pergi S1. So, bila dia jumpa 0, it will go back to the same state, which is state 0, where you goes whenever you found 0. State 3 is the state where you have found 1, 1, 1 tadi, but it hasn't found 1 and 0 yet. So, bila jumpa kosong, dia ikutlah semua state yang belakang ni tadi. Semua pergi ke state 0. So, state 3 as well, whenever it found 0, it will go to state 0. Okay, but when it found 1, now, stated here, design a non-overlap. So, kita tahu bila kita detect 1, 1, 1, alright, meaning that bila kita jumpa the fourth one, 1, 1, 1, first detection, and then kita dapat lagi 1 selepas tu, kalau dia overlap, kita boleh consider dia sebagai new detection. So, kita dah detect 2 kali. But bila non-overlap, then the fourth one cannot be considered as the second detection. So, 1, 1, 1, bila dia jumpa 1, dia kena pergi ke state yang mana dia jumpa 1 yang pertama. So, dia pergi ke sini. Output is 0. Okay, so that is how you draw them. Right? Okay. The designing step ni nanti saya akan bagi tutorial to you guys. You need to try by comparing dengan apa yang saya dah buat dan juga nota yang saya bagi ni, yang 11-12 step ni. Cuba buat, then you can compare with your friends or you can ask me untuk dapatkan kepastian betul atau tak apa yang you draw. Okay? Because this is the most important thing. State diagram. State diagram betul. The rest tu saya rasa should be no problem. Sebab state transition, you have already used them dekat dalam counter. Same way, cuma ada tambah 2 kolom baru. And then K-maps, you dah belajar daripada introduction to digital lagi. And then circuit diagram pun, you dah tahu macam mana nak lukis. Sama macam counter. Okay, number 2, state table. Okay, now, dekat sini saya buat dia sama je macam counter, cuma beza dia ada ni, input dengan output. So, saya letak warna dia pun dah letak X warna merah, Z warna biru. So, dia ikut apa yang ada dekat dalam diagram ni lah. Yang mana merah ni semua input, yang mana biru kat belakang slash tu adalah output. And then sini saya letak state lah, sepatutnya tak ada pun tak apa ni. Cuma saya nak supaya you tahulah. Okay, so state 0, binary is 0, 0. State 1, 0, 1. State 2, 1, 1. Okay. State 3, 1, 0. Kita terbalikkan dia punya condition ni supaya kita nak masukkan ni senang ke dalam K-maps nanti. So, 0, 0, 0, 1, 1, 1, 1, 0. So, kita translate lah. State 0 to 0, 0. State 1 to 0, 1. State 2 to 1, 1. State 3 to 1, 0. Okay, then the input ni akan tentukan ke mana kita akan pergi dekat next state dia ni. So, kita kena tengok. State 0 jumpa kosong. State 0 jumpa kosong, dia akan patah balik ke state 0. So, dia akan stay di state 0. State 0 meet 1. State 0 meet 1, it will goes to state 1. So, dia akan pergi ke state 1. State 1 meet 0, go back to state 0. State 1 meet 0, going back to state 0. State 1 meeting 1, going to state 2. So, state 1 jumpa 1, pergi ke state 2. 2 meeting 0, going to 0. Meeting 1, going to S3. So, state 2, 0 to S0. State 1, 1 to S3. Meeting 0, going to state 0. State 3, meeting 1, going to S1. So, state 3, meeting 0, going to S0. State 3, meeting 1, going to S1. Mana guys? Okay, sorry about that. Okay, now we are, okay, sekarang kita dah tahu macam mana saya dapat next state ni lah. State 3 going to state 0 bila dia jumpa 0 dan 1 ni semua berdasarkan kepada diagram ni. That's why the state diagram is very important. Design that you need to make sure it is correct untuk finite state machine. Okay. Okay. Sebab apa? You pun boleh tengok kalau diagram ni salah, you punya next state ni confirm akan jadi salah, JK input pun akan jadi salah, dan you punya K map akan jadi salah. So that is almost what we don't want lah. Right? Itu yang kita memang sangat-sangat tak nak lah. Okay. Right. Then convert lah S0 to sama macam bawah ni lah, 00, S1 01, S0 00, ni 11 and so on. Okay, so supposedly dua ni tak ada pun tak apa, you boleh congak je kan. 00 is state 0, jumpa 0 pergi ke mana, jumpa 1 pergi ke mana based on your circuit diagram. Dan saya punya apa tadi? State diagram. Okay, and then what else? Compare A and A plus lah untuk dapatkan JAK. So saya colorkan ini warna biru 2 ni untuk dapatkan this 2 column. A bar, compare, dapatkan 0 don't care, sama macam counter. And then this purple colored 00, dapat 0 don't care and so on. Saya comparekan B dengan B plus. Saya tulis kat bawah ni. Okay, then output. So how do I obtain this output? Just by looking back to your diagram. Okay, kita tengok state 0, meeting 0. State 0, meeting 0, output 0. Okay. So, output 0. State 0, meeting 1, also output 0. Semua kosong. Kecuali state 2, meeting 1 yang jadi 1. So, senanglah nak letak sini kan. State 2, meeting 1, the output will becomes 1. The rest akan jadi kosong. Okay. So, if you compare this transition table of FSM dengan counter tak ada input dengan output ni. Dia ada present state, next state dengan JK input condition. But for FSM kita ada input dengan output sebab kita tengok yang warna merah dengan biru ni. Okay. And then what else? We convert JK input condition and output into K maps untuk dapatkan simplified Boolean expression. Okay, so this is JA. Saya ambil yang ini. This is KA, this one. And this is JB, this is KB. So JB, KB. And then last one Z. Okay, so FSM kita ada output, so kita kena buat juga untuk Z. So you dapat BX for JA, KA X bar tambah B bar, JB sama dengan X, KB sama dengan X bar tambah A, Z sama dengan AB X. Okay. And what else? Lukis lah. Right? So, tengok. JA adalah BX. So, this is JA. Saya tarik satu daripada X. So, this one. Okay, ada external input. Kita ada X dekat sini. X. And then, pull one from B. Going to an AND gate. Going to JA. So, saya dapat BX. KA is X bar tambah B bar. So, here, X bar from the input tadi. External input. Saya barkan dia guna NOT. And OR kan dengan B bar. And then supply it to KA. So, saya dah siap JA dengan KA. JB adalah X. So, I pull one from output X. Mana X ni? X. Then, terus masuk ke JB. Which is this one. And then, KB is X bar tambah A. So, pull one from X bar. Pull one from A. Going into an OR gate. Dan masukkan ke KB. And then clock input coming from the same source. Then last one, ZABX. So I'm using 3 input AND gate. Pull one from X. I pull one from B. And then I pull one from A. And then going out to Z. So you dapat dia punya circuit design. So if you design this, contohnya kalau sekarang kita guna Tinkercad ataupun if we design it on the breadboard dekat dalam lab. So this is your clock source, this is your toggle switch, this is your LED. Okay, ini clock source, toggle switch, ini you punya LED. So bila you detect 111, then dia akan menyala lah output dia. Okay, so that is the first example. For non-overlap, maksudnya dia tak boleh overlap. Detection dia tak boleh bertindih. We look into another example here for overlap. Design an overlap millisequence detector using circuits that will produce output high for the input sequence of 000 using JK flip-flop. Okay, so now kita tahu detection yang kita nak adalah 000. So the straight line will be 000. Tengok yang merah. State 0 to state 1, 0, output 0. State 1 to state 2, 0, output 0. State 2 to state 3, 0, output 1. Kenapa dia output 1? Sebab dia dah jumpa 0, 0, 0. Okey, bawah ni salah. Okey, in your notes, please. Ini sepatutnya bukan 1. Where's my text box? You should. Okay, this is where you detect the first 0. And then this is when you detect the second 0. Right, then this is when you detect the zero. Okay, please change in your notes. Okay, so state 1 is where you found the first 0. State 2 is when you found the second 0 consecutively. And then the third state is when you found the third 0. Maksudnya you found yang dia nak lah. 000. Tadi 111 kan? Tadi 111. So dekat drawing tu saya lupa nak tulis kat bawah. Tukar kat bawah. Okay, so 000 has already been found. Now we move back to state 0. It has already met 0. Dia tak jumpa 1. So bila jumpa 1, patah balik ke state 0. Dan dia punya output akan jadi 1. State 1 sama, already met 0, haven't met 1, going back to state 0. State 2 pun sama, going back to state 0 kalau jumpa 1. Okay, dekat state 3 ni yang dia jadi a bit tricky dekat sini. Sebab kita tahu dia nak overlap. So now 0, 0, 0. Tiba-tiba you jumpa 1. So meaning that you tak ada jumpa bit yang dia nak. You want to meet 0, 0, 0. But accidentally you terjumpa 1. So meaning that you are going to the same state where you found the first unused one. So pergi ke state kosong balik sini. So 1/0. So patah balik ke sini. Okay. But when it found 0, another 0. So 0, 0, 0 dah jumpa. And then state 3 jumpa another 0. Okay, so dia jadi 0, 0, 0 jumpa. Lepas tu kita baca dari sini pula. 0, 0, 0. Dia jumpa juga. Sebab overlap. Meaning that we can use state 2 punya 0 ni untuk detection yang pertama. Dan juga kita boleh gunakan dia ni sebagai detection yang kedua. So dia akan jadi 0, 0, 0 sekali jumpa. 0, 0, 0 the second time dia jumpa. So ini dikenali sebagai overlap. Tadi non-overlap. So dia patah balik ke state belakang. Kalau overlap, dia patah balik ke sini saja. Sebab kenapa? This is where you can go when you found your sequence and your output is 1. So output dia pun jadi 1. So instead of only one output becomes high, there are two outputs high. So 0, 0, 0 first detection, 0, 0, 0 second detection. Okay, so that is the differences between tadi non-overlap. Okay, macam ni kan, 1, 1, 1. Sepatutnya bila dia jumpa 1, dia boleh overlap dekat sini je, dia jumpa. Tetapi sebab dia non-overlap, so dia tak boleh patah balik ke sini. Dia kena pergi ke state 1. But this one, it doesn't have to go to here, state 1 bila dijumpa kosong. Sebab dia adalah overlap. Kita boleh bertindih. Okay. Detection can be overlap. So 0, 0, 0, first detection, and then 0, 0, 0, second detection. Okay. What else? Transfer everything lah. State 0, state 1, state 2, state 3. Tukar kepada dia punya binary. And then the input column 0, 1, 0, 1, 0, 1, 0, 1. Next state depends on this diagram lah. State 0 jumpa kosong ke state 1. State 0 jumpa kosong, state 1. State 0 jumpa 1, state 0. State 1, meeting 0 going to state 2. Meeting 1 going to state 0. State 2, meeting 0 going to state 3. Meeting 1 going to state 0. State 3, meeting 0, loop balik dekat dia. And then meeting 1 going back to state 0. Okay, and then convert pula dia ke state-state ni kepada dia punya binary. Compare dapatkan JA, KA, JB, KB. And then output. Okay, notice that only 2 places where you have output S1. Bila S2 jumpa 0 dan S3 jumpa 0. So S2 meeting 0, output is 1. S3 meeting 0, output is 1. And the rest jadi kosong. Okay. Then transfer JA, KA, JB, KB, and Z to K maps. So JA B X bar, KA X, JB A bar X bar, KB X plus A, Z equivalent to A X bar. So lukislah JA sama dengan BX. So this is JA. I pull 1 from B. I pull 1 from B X bar. Sorry, pull 1 from X bar. So ni input. This is output. This is clock. This is VCC untuk set dengan reset lah. So X bar and B going to JA. KA comes from X. So just pull 1 from X dari sini terus masuk ke K. JB is A bar X bar. So I pull 1 from X bar. I pull 1 from A bar going to JB. KB is X plus A. I pull 1 from A. I pull 1 from X and then going into KB. So siap. Clock, same source going to both of the flip-flop. And then last one Z, A X bar. So I use AND gate. I pull 1 from X bar, another one from from A, and then the output is Z here. So this will be connected to LED. This is your switch. Okay, toggle switch, switch button, pull switch, whatever, apa-apa switch yang kita pakai lah. Okay. And then this is your clock. Then bila you buat 1, 1, 1, dia akan jadi high. If the fourth detection is 1 as well, dia still akan jadi high. Okay. So that is it lah about FSM and some of the example. So dekat sini saya bagi 2 example lah. Satu for non-overlap, satu lagi for overlap. Okay. But saya ulang sekali lagi. Ni FSM design ni 3 slide ni. These 3 slide is the most important part of finite state machine. If you can understand these steps, then yang ini tak akan ada problem. Dan yang lagi 3 ni tak akan ada problem lah. Sebab 3 ni you dah buat dekat counter. The same thing. Cuma dekat sini tambah 2 kolom baru. Itu saja. Okay. So that is for our lecture. Okay. I have upload to you your tutorial 4B, the finite state machine. Okay. So dekat sini saya terangkan sikit lah apa yang overlap, apa yang non-overlap. Okay, so this is your worksheet lah yang you boleh pakai untuk you buat nanti. Okay, now for 3 bits, kita tahu kita boleh detect ada 8 lah. 8, how we call it, combinations. 000, 001, 010, 011, 100, 101, 101, 111. But not all of this detection punya arrangement ni ada overlap dan ada non-overlap. Okay, kita tengok dekat 000, obviously dia ada overlap. 000, kita jadi high sekali. And then 000 kali kedua warna hijau, dia jadi high lagi sekali. Kalau non-overlap, kita perlukan 6 0 lah. So 000, dia akan jadi high. And then 0 ni dia akan jadi low. 0 kedua dia akan jadi low. 0 ketiga baru dia jadi high. So ini beza 000 overlap, 000 non-overlap. Okay. 001 dia tak ada overlap, dia ada non-overlap sahaja. Sebab apa? You need to find 001 untuk jadi high. And then for the second detection pun sama. You need to find another 001 baru you jadi high. 010 ada overlap. Okay, so 010, so dia akan jadi high sekali. And then let's say the fourth bit is 1. And then the fifth bit is 0. So dekat sini kita dapat lagi another 010. So detection kali kedua. So dia akan jadi high dekat sini. Kalau overlap. Kalau non-overlap, obviously you need them to be twice lah. 010 detect sekali. And then dia perlu 010. Baru dia jadi sekali lagi detection. You boleh compare yang ni dengan ini. Okay, dia kekurangan 10. Yang ni tak ada 10, ini ada 10. 011 tak ada overlap, 011, 011 baru dia dapat detect. 100 pun tak ada overlap, 100, 100. 101 ada overlap, so 10101 dapat 2 kali. 101, 101 dapat 2 kali. So this is overlap, this is non-overlap. 110 ada 110, dia tak ada overlap, ada non-overlap sahaja, dapat detect 2 kali, sebanyak 6 bit. 111 sama macam 000, so boleh detect secara overlap dengan 4 bit sahaja, or you can detect without overlap by using 6 bits. 111 first detection, 111 second detection. So you have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You ada 12 possibilities sahaja. Okay, yang you boleh buat. Okay, kita hanya we only use 3 bits. We are not going to use more than 3 bits. Dalam you punya final exam, dalam you punya lab pun sama. Saya buat 3 bits sahaja. Okay, so this is the only combination yang you boleh jumpa lah. So now, for this tutorial, design the Mealy FSM for the following. Okay, so 000, non-overlap. Overlap solution in the lecture notes. Okay, tadi kan saya dah buat dekat dalam lecture notes tu ada 000 overlap. 0001 non-overlap, 010 non dengan overlap, 011 non-overlap, 100 non, 101 non dengan overlap, 110 non, 111 overlap sahaja because non-overlap solution has already been discussed from your lecture notes. So you ada 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lah, lebih kurang 10 design you kena buat untuk tutorial 4B. So use the worksheet attached together to write down your solution. So you boleh pakai sini lah. Okay, saya dah bagi the straight line. Lepas tu you lukis lah yang seterusnya. Yang ini nak jumpa apa? Katakan first 000 non-overlap. So 0, 0, 0, 0, 0, 0, 0/1. Okay, sini kalau jumpa 1 pergi mana? Jumpa 1 pergi mana? Jumpa 1 pergi mana? Okay, yang ni pula jumpa 0 pergi mana? Jumpa 1 pergi mana? Dia overlap atau tak overlap? Tengok soalan. Then transfer present state input. Saya dah letak lah. Present state 00 tu adalah state 0. 01 adalah state 1. 11 is state 2. 10 is state 3. Input saya dah letak. So next state. Lepas tu compare dapatkan JK. Output pun you kena letak. Transfer to the K-map. Dapatkan simplification. Boolean expression. Then lukis. So you can use this worksheet lah untuk you punya design ni. Okay. So that is the plan for your tutorial this week. So for which group, yeah? Okay, for LO1 BO3, which is tomorrow. And then on Thursday, LO1 BO1, LO1 BO4. Dan juga 2 student digital electronics. Okay, so please proceed with this design. Mana tadi? Please proceed with the design of this. Inilah tutorial 4B ni. Cuba buat dulu untuk 000 non-overlap. Dah siap buat 001 non-overlap. Okay. For tomorrow's session. As well as for yesterday's punya session. Yang LO1 BO2 tu yang saya terpaksa cancelkan kelas. Sebab kita dah. Okay. We miss out this topic last week. So sepatutnya minggu ni kita buat dia punya tutorial. But because last week kita miss, so saya tak boleh nak buat dengan orang. So for L1 BO2, as I already requested yesterday, during your ample time, masa you ada masa free nanti, cuba buatlah. Okay. So that is for this week punya tutorial. Okay. Kelas malam, kelas esok dan kelas Khamis. So I will not be arranging any team session lah. Please do it by yourself during your personal time. Buat masa kelas tu lah. Jadi kan esok pukul 10.12 kita tak ada team, so you buat solution untuk tutorial 4B ni. I have already uploaded dekat dalam e-learning. Okay. So worksheet pun saya dah bagi, cuma tinggal you nak lukis, buat buat transition table, buat K-map, then draw diagram. Okay, approximately lebih kurang 10 lah kalau ikut soalan dia ni. Okay. So no team session for this week. And then same goes for next week. Next week kita memang cuti. Isnin, Selasa, Rabu tak ada. Khamis pun kita tak ada kelas lah. Khamis dan Jumaat pun kita tak ada kelas. But I will make a replacement class somewhere after that lah. Kita akan buat malam or anything. Tapi you don't need to attend. Just make sure you can proceed dengan ni, tutorial 4B ni. Because you want, I don't think you can finish all 10 in one session. Okay, so cuba untuk session minggu ni punya tutorial, especially kelas yang esok semua ni lah, termasuk kelas malam, cuba buat dulu 3 atau 4 untuk minggu ni siap. And then nanti lepas saya buat lagi untuk siapkan semua ni lah. Okay, so for these 2 weeks, our tutorial only focus on this finite set machine punya tutorial. This week dengan next week. Tapi next week tu you buat nantilah lepas saya. Okay. I'm not asking you to do it on the pada hari raya ke apa ke, no. Okay, bila you ada free time. Okay, Sabtu Ahad ke bosan, dah tak ada buat apa-apa. Kan hari Isnin dah nak start kelas balik minggu depan. The other week lah. You can try to complete your tutorial ni lah. Okay, that is for our class tomorrow punya, next week punya tutorial dengan this week punya tutorial. And obviously next week punya lecture pun tak ada lah. Yang itu nantilah. Nanti lepas saya baru saya fikir macam mana nak buat. Okay. Right, so that is about FSM. Where you can find that in the tutorial part lah. Okay, ni lah tutorial 4B. So, you can find here or dekat dalam digital electronics pun saya rasa saya dah upload. Ya, saya check. Okay, dah tutorial 4B pun ada. Okay, so please proceed with this for these 2 weeks lah. This week dengan next week. Okay, and then one more thing that I want to discuss with you is about your assessment. So today is the day I'll be giving you your task 2 of your assignment. So ini untuk digital electronic principles. Untuk digital electronics is assignment 2. Okay, assignment 1 yang kita buat berkenaan dengan video yang you dah submit tu adalah. Yang mana belum submit, please submit. Ada yang belum submit. Yang digital electronics belum submit, please submit to me your assignment 1. Okay. So this one is assignment 2 for digital electronics, but for digital electronic principle, dia adalah task 2 untuk assignment. Okay. So we'll go to the assessment. Verify. Okay, task 2. So this is your question, same for digital electronic principle dan digital electronic. Sama je soalan. Working as an engineer is one of the electronics devices in one of the electronic devices company. You and your team are assigned to design a digital task bay which will be able to manually count from 1 until 15. So your design circuit will be presented to your manager with the following items. Detailed design procedure with complete circuit and simulation result. Techno-pronoun execution plan, macam mana, marketing, selling strategy, Twitter, FB, the costing and the selling price of the products with justification. So what is your selling point? You are required to record your presentation of your findings and upload the link to the VLE. The duration of your video presentation is about 10 to 15 minutes. Okay. So yang ni for assignment 2 ataupun assignment task 2 ni, basically it is lebih kurang sama macam task 1 ataupun assignment 1 itu. Cuma task dia je yang, cuma dia punya soalan yang berbeza. Where here you are required to design a digital task base which will count from 1 until 15. So bila 1 until 15 ni you boleh design menggunakan counter. Okay, the one that you have learned from the previous week. Okay, how to count from 1 until 15, back to 1 and so on lah. Okay, so you kena tunjuk design procedure, dia punya circuit dengan you punya simulation result. Tak kira lah you nak guna multi-sim ke, you nak guna Tinkercad ke, whatever, but mesti ada simulation result. You kena tunjuk dekat dalam presentation-nya. Lepas tu you discuss lah macam mana you nak buat marketing and then you punya costing. Okay, apa you punya selling point, macam mana. Right? So semua tu buat dalam presentation with your slide lah. Slide tu kena ada lah 3 benda ni. Right? So that is the performance criteria yang akan memberikan markah you untuk you punya task 2 ni ataupun assignment 2. Okay. So I have basically moment ya guys. The what we call it, the instruction. Okay, so I'll share it with all of you via our L1 BO2. Okay, L1 BO1. L1 BO3. And L01 BO4. So you may check your WhatsApp saya ada letak dia punya instructions. Oh, saya share dulu. So basically this is the instructions lah. Please proceed with the same teammate for task 1. Yang you buat masa task 1 itu hari, yang mana you punya teammate you buat dengan dia. Submission is latest by 11:59 PM on the 15th of May. So 15 hari bulan 5. Okay, approximately seminggu lepas raya lah lebih kurang. Okay, submit dekat VLE, saya dah buat link. File to submit adalah video 10 to 15 minutes and then your presentation slide. And then video content instruction stated in the assessment sheet. Okay, so kita tengok balik assessment sheet dia. So 3 ni lah. Ini benda yang kena ada dekat dalam you punya presentation. Okay, so that is for your task 2 assignment ataupun assignment 2. Right, submission 15 hari bulan 5. Okay. Alright guys, I think I open to any question lah. Ada soalan ke? Untuk digital electronic principle, this is your submission link. Okay, soalan dia you kena klik dalam ni. Saya tak dekat dalam ni. This is the question Submission 15 Mei. Ada 19 hari lagi. Okay. So soalan dekat sini. Jangan pula you cari-cari tak jumpa. Ada dekat sini. For electronic, digital electronic ada dekat sini lah. This is the submission. Tapi dia punya soalan saya letak dekat atas ni je. Okay, assignment 2. Okay. Alright, so I'm open to any question. Ada soalan nak tanya? Regarding FSM, regarding tutorials dan regarding our assignment 2 atau task 2. Ada soalan tak? Tak ada soalan
Tak ada, tak ada.
Ada, okay. Kalau tak ada, then I'll share the attendance with you guys. Mana? Digital electronics principle. Okay, please scan your attendance first. Okay, for those yang dah dapat scan and have no other questions, you may leave the session. Okay, insyaAllah I'll see you after raya lah. Okay. For those yang tak boleh scan, please stay. Kita akan buat manual. Dan kepada tu, dua student digital electronic, please stay. Okay guys. So that's it from me. Thank you. Please remember apa yang saya dah minta you buat ni lah. Okay, nanti video ni saya akan upload dekat dalam VLE. You may refer to that lah in case if you forget apa yang you kena buat and so on regarding your tutorials dan regarding your assignment. Okay, thank you guys. Selamat Hari Raya. Maaf zahir batin. Pada yang pulang ke kampung, drive carefully. Okay. Apalah, berpada-pada lah. Right? Thank you guys.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Assalamualaikum.
Selamat Hari Raya, sir. Selamat Hari Raya,
Sama.
sir.
Hari Raya.
Thank you, sir.
Okay. Siapa yang tak boleh scan ada ke?
Selamat Hari Raya, sir.
Raya. Anybody who can't scan?
Sir,
Ya.
nak tanya tu,
Boleh.
sir yang dekat Valley tu dah keluar markah assignment kan sir?
Itu task 1 sahaja.
Oh, okay sir.
Belum task 2 ni nanti saya akan campur balik lah.
Lab pun belum kan sir?
Lab saya belum marking lagi. Belum habis.
Okay, thank you sir.
Baik, nama Hafiz.
Sir,
Ya.
saya manual. Daniel.
You ni kan, kelas 1 lagi kan?
Aha.
You dengan Hasnul. Okey, tak apa. Daniel dengan Hasnul nanti saya buat manual.
Okay. Thank you,
Right,
sir.
thank you. Right.